Okay, so in this video we discuss question 13 and 14. Question 13, 1.12 shows uniform electric field with a strength of 2.7 times 10 to the power 5 Newton per coulomb. And the distance between the plate is 0.0078 meter. Proton is placed inside the field at A. Proton is positive. Yeah, it then moves from point A to point B. Okay, first question, the potential difference between A and B, which plate has the higher potential? So they just want you to state which one has the higher potential. So you can follow the direction of electric field. So E is pointing downwards. And if you guys still remember, I always told you E punya directions from higher V to lower V. So the higher is plate A. So plate A has higher potential compared to plate B. So I can write VA is bigger than VB lah. Question B, they want you to find the work done by the electric field on the proton. So if you want to find the work done, you have to use Q delta V. So the first thing that you need to find is delta V. Okay, Q is given. Q is not given, but instead it is proton. So you can substitute a constant over there. So delta V, you can use E equals to delta V over, E equals to delta V over D. That one formula. So E equals to delta V over D. Okay, this one valid for two metal plates. Okay, electric field, uniform electric field between two metal plates. So my delta V is equals to E, which is 2.7 times 10 to the power of 5. Okay, stated over here. And then the distance D is 0.0078. Okay, your delta V, you will get 2106. Sorry. Yeah, 2106. Okay. So this is the first step. The second step, obviously, you have to find the work. Okay, because this is a positron, so you substitute with a positive values of E. Because positron and electron, they basically have the same charge. So here I should get 3.37 times 10 negative 16, and the unit for work is joule. For question 14, it says that the electric potential of a point, which is at a distance x from point charge, is 600 volt. The electric field strength at that point has a magnitude of 3 kilo nano per coulomb. Determine the distance of the point from the point charge. So dia kata at the point x, at a certain point, let's say put point P, and this is the charge. The distance is x, and then you have values for V and E. So V is positive 600 volt, so immediately you know that this one is a positive charge, and E is equals to 3 times 10 to the power of 3 Newton per coulomb. Okay, so you want to find the values for x, the distance of the point from the point of charge. Okay, so you have two formulas, one for V and another one for E. Formula for V is KQ over R. Okay, on the other hand, formula for E is E equals to KQ over R squared. Okay, so because we are talking about the same charge, we only have one charge, right? So basically this charge will produce potential over here and electric field over there. Okay, what we are talking about the magnitude only. So basically I want to find the values for X. Maybe I can rewrite this one in terms of X. Okay, so you can see that if I want to find X, this one is actually very similar equation, except that another one has X squared compared to X. So if I do 2 divided by 1, so I can cancel out almost everything. Sorry, because X is down there, so I think 1 over 2 is better. Okay, if you do it the other way around, you get 1 over X, and then you just have to invert it. Doesn't really matter. So V over E be equals to KQ over X divided by KQ over X squared. Okay, you can leave it like this, or sometimes students might find it a little bit confusing. So I just rewrite that one. Basically what I'm going to do is that instead of division, instead of dividing by that, I change to multiply, but I invert the below one. So it becomes X squared over KQ. So you can see clearly this one cancel out. And this one you left with X. So your X is equals to potential over E. The potential is 600. And then your E is 3 times 10 to the power of 3. So your X here, you should get 0.2. And then this is the SI unit, so it will be in meter. Okay, for the next question, question B, they ask you to find the charge of the point charge. So now they want to find Q. Okay, you can take any equation, so I prefer to do this one because it looks simpler. So use that formula, V equals to KQ over R. Okay, so if V has a negative, you have to substitute negative here. So this one is positive, so just leave it as positive. We need to find Q. R is 0.2. Range and solve, you should get Q equals to 1.33 times 10 to the power of negative 8. Let's say the values for V is negative, you will have a negative over here, kalau. So if you get those values, just leave it as it is. Are they negative? Just leave it there.